And I'm going to start off just by finding out how many of you happen to be iPhone users. You got your iPhone. I know I saw a lot of iPhones. Okay. So if you are an iPhone user, it's possible, maybe it didn't happen, but it's possible back here a few years ago, you may have been one of these poor unfortunate souls that had some of your data stolen. Any of you admit, like I am, to still being a Yahoo email address user? I still am. No? Okay, good. I'm not alone. I always get people to give me looks when I give them my email address, like I'm so in the past.
Well, you didn't say AOL.
Well, AOL would be pretty bad too, yes. But my excuse is that I just haven't had the same email address for over 20 years, and I don't want to change it. But that being said, I was lucky. I was not one of these Yahoo users that lost a lot of data and was a victim of this terrible attack. How many of you are one of these users, this website? You're an avid user? Anybody? User of this web application? Nobody? No hands? How about that? Wow, gee. If you were, you may have also lost potentially some confidential data if you were a user of this web application. And obviously the moral here I'm getting at is we're under attack. Web applications are under attack. Many well-known tools like PlayStation and hotels are under attack, and they need help. And that's why we spend a lot of time talking about my favorite product at F5, our Application Security Manager, ASM, also known as Advanced WAF or AWAF. We'll talk a little bit about, what's it called now? Talk about that. This is when, last week we talked about Advanced Firewall Manager, ASM, and I would say it's a great product. It does what it's supposed to do. It's functional, but it's not like overly exciting. It's a product that does its job. This is our exciting product. This is the flash that we have to shine and show amazing things that we can do with ASM. Now, one of the challenges I've seen for years with getting ASM out there and getting our customers to adapt to it and use it is it has kind of a reputation. People think of it as a challenging product. It's complicated, difficult. And so I try to spend a lot of today sort of dispelling that a bit to show that it's actually not as difficult to get ASM set up when you know what you're doing. One of the concerns I had when we first came out with this new concept called Advanced WAF, AWAF, which is really just additional features, additional things you can add on to ASM, was that there was going to be this possibility that a lot of sales people are just going to want to go out and talk about one or two specific Advanced WAF features without actually showing them how to use the core product itself. There's all these great things we can do with ASM, but at a minimum, at its beginning, we have to start off properly. We have to start off by creating a good security policy. So I don't want anybody to go out and just start showing some of the advanced things we can do if they haven't yet really learned how to build the policy they need. And that's what we spend a lot of today on, is showing how to build a security policy through these 4 lessons. Now tomorrow, you guys are all going to get demos that are ASM related. They're ASM demos, and they're all additional features, really cool features that we can do. And I want you guys to show each other. You guys are going to be teaching each other how to do these features in the form of giving demos. But before you do that, I want you to understand just how to use ASM to begin with. So we'll start off in lesson 1, just like we did with AFM and APM, just kind of giving the overview of why we have this product at F5, how we're pushing it, what the purposes of it are, And we're going to go over a lot of some of the core things that ASM does in terms of HTTP protection. So we're really going to delve into the HTTP protocol a little bit, which can maybe help some of you for your test tomorrow, because you may see some questions about HTTP. And then in lesson 2, I'm going to give you an example of one easy to add additional security feature called enforcing file types. Just show you how we can take a policy that actually is okay and we can just add something additional to it to make it better. We'll also talk a little bit about our signatures, our attack signatures. Then after lunch, we'll get into the meat of policy building and talk about why this can be challenging. I was taught years ago, or told years ago, that if you try to teach yourself how to play golf, you're probably going to do it wrong. But unfortunately, when you are taught properly, it becomes more challenging because then whoever's teaching you has to unteach you the wrong way you did it before they can teach you the right way. Policy building can be done the wrong way. You can make a lot of mistakes. So I want to make sure that you guys are building your security policies correctly from the start. So we're going to talk about some key aspects, such as whether we're using manual or automatic policy building, where the requests are coming from, are they trusted or untrusted, and then we'll sum it up with 3 of probably the most important concepts about policy building, which is learning, staging, and most importantly, enforcement. So we'll do all that after lunch. But let's take a step back in time, like we're going back to Portland, as I said, back in the late 80s, but actually not quite as far as the late 80s. Raise your hand for me if you are over 45. Over 45. Okay, so about 3 of you. The rest of you might remember this, but those of us that are over around 45 can remember when the internet first was really coming to be, and we could go to these things called websites. How did most of us get to the website back then? How did we get onto the internet? Because everybody know? Some say DSL. Before even DSL. Yeah, the dial-up modem where you had to use your phone line and it made this awful noise. Connected. And once you connected, then you could go to these really cool pages that companies had, like momandpopflowershop.com. This is actually the F5 website, the very first one. And more often than not on these web pages, you just got some basic information about the place, maybe the hours of their operation, their address, maybe 1 or 2 images. There's a couple of really sophisticated images there on the F5 website. But we had to keep those images on a small level and really low resolution because this dial-up connections, we didn't have a whole lot of bandwidth. So we made these web pages pretty basic. Most of what, or in most cases all of what was necessary to build that web page for the user was stored on this one web server. That was way back then. Now, in this current day, web applications have changed so much. Sometimes I think to myself, God, I can't believe we can do some of these things now, either on my computer or even more so on my phone. Like, for example, I don't have to go to the bank anymore. I can actually deposit a check somebody has written to me just using my phone. I've taken a photo of it. I'm still waiting for the day where I can actually use my phone as an ATM and get cash out of it, but that hasn't happened yet. But next best thing, we've got things like Venmo where people can share cash with each other. I think Venmo is an amazing concept because I've had over the course of my life way too many times where I'm out with somebody and I'm like, okay, so your share is 25, and they're like, oh, I don't need cash right now. I'll pay you back. I'm like, all right. And then like 2, 3, 4 weeks later, a month later, I'm like, where's that money? I haven't seen you for a month. Venmo makes it so much different. Oh no, you can Venmo me right now. Get on your Venmo, send me I'll give you cash. I love that. But just the idea of what we can do now when you're going to book your travel to come here to boot camp, You didn't have to call the travel agent like we used to have to do and sit there on the phone with the travel agent while they told you all your options. You can just get on and do it all yourself. So web applications have become so much more useful for us as users. So much more useful. The problem is, for these organizations that are hosting these web applications, there's a lot more layers to the application in terms of not just the web server, the app server, and scripting, but more often than not, they're storing data for us. Anytime you can go to a website and log in and see your information, your profile, your history of this and that and the other, all that data is being stored by them. And the vulnerability, what's at risk for these organizations is all of this. I always say that whenever something is made better for the good guys, it becomes a threat to the bad guys. Somebody wants to take advantage of this. And that's what's been happening these last many, many years, is the hackers are trying to exploit all of this amazing opportunities that we have to do our online banking and our travel and transferring money. Anytime we're transferring money, there's a risk there. It gets intercepted and my money goes to the wrong place. A lot of risks involved. The application security state continues to be a challenge and continues to grow as a challenge. As opposed to getting better, it's only getting worse year after year. So, and all of the exploits an organization faces, everything from the physical, dangers all the way to network attacks and everything else, almost 1 in 3 of the issues that organizations face deal with their web apps. Almost 1 in 3. That's a pretty high number. And about 2 out of 3 of those exploits are exploiting known problems in a web app. In other words, things that we should have been able to fix. Somebody should be able to fix that. A lot of organizations say, no, I got secure coders. They know what they're doing. No, they don't. They're leaving vulnerabilities out there. Now, unlike the network attacks that we talked about last week, where the real main goal of a network attack is just the notoriety of saying I was the one responsible for taking down, this service for an hour. Majority of the motivations behind these kinds of attacks, application attacks, is money in some manner. Whether we're getting data, we're going to get the data and sell the data to somebody else. We're going to financially get something financial out of it. That's a pretty big motivator for hackers. And that's a good motivation for keeping application attacks new and fresh and more difficult for us to identify when we're on the organization side. Still, about 1 in 3 of these attacks are exploiting SQL injection. We're going to talk a little bit more about SQL injection later. I told you last week that I had the opportunity to go to a OAuth convention, and that unfortunately was a little bit lacking in terms of the dynamic presentation, but I did pick up on one thing. I had thought when going down there that I was going to learn all the newest, latest, and greatest big money-making attacks that are out there. And they had 2 that were still listed up at the top. SQL injection was one of them. The other was cross-site scripting. I thought that, maybe those were yesterday's news. They're not yesterday's news. Those are still 2 of the biggest threats organizations face, is SQL injection and cross-site scripting. And again, kind of like this one up here, that about 1 in 3 of the web applications out there that have been tested, and this is worldwide, have at least one serious vulnerability. 1 out of 3. Again, these are from organizations that feel confident that their web apps are secure and coded properly. They're not. But again, this was the takeaway that I got out of that OAuth convention. These are still 2 of the biggest threats organizations are facing. And the nice thing about this statistic is that this is something ASM can do practically with hands behind his back and blindfolded. One of the easiest things for ASM to take care of. And you're going to do that in your very first exercise. You're going to see that we can take a vulnerable web app and protect it against these two in a matter of seconds. It's not a smoke and mirrors exercise, it's a real exercise. In just a few seconds, we can protect a web app against these two. That's a pretty cool thing. Now, what are organizations doing today that are not using any kind of a WAF, a web application firewall at all? They've heard about these issues, they recognize these issues are real. All right, we've got to do something about it. All right, so we've deployed the state-of-the-art network firewall, maybe even AFM. They're using really good SSL encryption and decryption. Their website uses HTTPS. Great. I should hope it does. They have hardened all their servers, their web servers, their app servers, their database servers by doing things like removing unnecessary user accounts, disabling unnecessary services. They've gone through this hardening checklist for all their servers, and they keep them regularly patched with all of the patch updates that come. Of course, that's a pretty big undertaking if you've got a large data center and tons of web servers and database servers. A lot of work to do that. And most importantly, they've made sure that all of their coders that are doing all of their application coding are using all of the security best practices when they code these web applications. That's what a lot of organizations are doing. The problem is, you're probably thinking to yourself, well, those aren't suitable mitigations for these application layer attacks. And they're not. When I now have the malicious user, and they're trying to launch an attack against my web server or any other component of my web application, the first thing, SSL. SSL is great. Everybody uses SSL now. In fact, as we'll talk about tomorrow with SSL Orchestrator, a majority of web applications are all now using SSL. It's on the rise. But SSL, what it's for, is for protecting the data in transit. It's making sure that when I send a request to a server, it can't be intercepted and viewed and manipulated. But it doesn't actually stop an application attack. Our network firewall, no matter how state-of-the-art it is, even if it's ASM, which we think is a great network firewall, they only go up to layer 4. And all the attacks we're talking about, everything we're talking about is layer 7, which means it's just going to the web server's IP address over port 80 or 443. Every application attack is going to the web server on the right port. So for the network firewall, it's all going to look completely legitimate. And it's just going to pass all of that through. And possibly, a lot of network firewalls are just completely blind to SSL traffic. So anything that's going over HTTPS just passes right on through. The funny thing about using HTTPS, we're going to talk about this tomorrow as well. This is a great security feature. It's great. It helps us. But as I just said a few moments ago, when there's something that helps us, someone's going to find a way to take advantage of it. And the hackers are doing that as well. They're actually using the fact that a lot of our security components are just passing the SSL traffic through. They're using that to their advantage by using SSL to send all of their application attacks. So in a kind of a funny way, SSL isn't actually helping us prevent application attacks. SSL is actually helping to ensure the application attack makes it here successfully. That's not great. And even if the organization is using all the best hardening practices, they're patching regularly, and they're using secure coding, there's issues with that as well. One of them is we're never going to have full zero-day attack protection. We're only as good as the last patch and the last coding practice. But even if they feel somewhat confident in this, okay, you know, I think I'm okay with that. I think I'm all right. I have another argument for that. And this is the slide, by the way, that some of you are asking. This is the slide coming up that took me over a day, probably about 2 days to create. I used to do it as a whiteboard. And since I shared this training with a lot of other trainers, I thought, I should replace the whiteboard with the slide. As I got into it, it got deeper and deeper, but I wanted to illustrate my point. So let's talk a little bit, let's review a little bit about why there's so many benefits to using just the BIG-IP in general. Just in general. So for example, we have our 2 web applications back here, a pool of servers, and right now they are both HTTPS web applications. And we might have configured BIG-IP to just pass SSL traffic straight on through, but you guys all know that's not the best way to do that. The best way to do it is to put the certificate on the BIG-IP, do SSL offload, and then we can actually take certificates off of the servers. Now, what is the real benefit? The real reason behind why using SSL offload is valuable for the web applications.
Performance.
Say again?
You can inspect the traffic.
That is good. That's certainly a benefit.
Performance?
Performance on what?
Just overall.
What's getting a performance boost on this picture?
Servers.
The server, yeah. We're getting basically taking away some of the work that the servers had to do. They no longer now have to do any decryption and re-encryption, which is a CPU-intensive task. Not only are we doing that all on the BIG-IP, but the BIG-IP does it faster. And in some cases, it's going to do it in hardware. So it's even going to be even faster yet. Absolutely. Another thing is we could be doing HTTP, I'm sorry, I'm going to jump ahead there. So here, this graphic is saying that we've also decided to do HTTP compression, to compress all the data between the web servers and the clients out there, take advantage of our bandwidth as much as possible. But another option we had was to take that HTTP compression off of the web servers and do all the HTTP compression on the BIG-IP. So why is that valuable? To do that for my web applications.
Resources.
I'm sorry?
Servers.
A little louder. I should have told you, I lost one of my hearing devices over the weekend, which is awful.
Oh.
So now I'm down to 1 ear, so nice and loud.
Less resources are needed on the servers.
It's essentially the same idea. I'm taking away the work that these servers were doing with compression and decompression and compression, and I'm putting all that work on the BIG-IP, where it's better and faster. In fact, why do we even have these web servers? What are they here for? Why are they sitting in my data center? What is their role? What is their job?
Well, they serve the application, they run the business service.
They're supposed to receive web requests and send the web responses, right? That's pretty basic. So why would I want to give them any additional work beyond that? Anything I give them to do beyond that is just taking away from their main job. So even if I had all of this on the servers, we can probably assume that their performance is going to go down as a result. So we want to take as much of the unnecessary work that we can do on the BIG-IP and take it off of the servers. Keep them low utilized so they can serve up content faster. That is a great goal to have. So let's go back to that example we just had where they say, you know what, I got all my servers hardened, they're all patched, I've applied secure application coding, my app developers know what they're doing, so they've got all the good practices in here. The question is, do we also want to add the additional job on the servers themselves of playing what I call the traffic cop, deciding that this request is good, this request is fine, this request looks dangerous, I better discard this one. When we give that job to all of my web servers, you have to remember we're getting thousands of requests, possibly per second. And so that's going to become a very challenging job, especially as the traffic increases. And the web server is like, good request, bad, good, bad, good, bad. And even the best traffic cop on the web server is still going to make some errors. It's still going to potentially send some bad requests through because no secure coder is perfect. And they typically miss a lot of flaws. So the question is, just like SSL encryption and decryption, just like HTTP compression and decompression, do we want to put this additional task on our web servers and make them do more work? Or would it make more sense to take that job off of the web servers so they can just focus on their job and put it up on the BIG-IP in the form of ASM, our web application firewall? This is actually a great way to do it because ASM can pick up a lot of flaws that we had a hard time doing here, or that we might have missed down there. It's also much faster. It's on the BIG-IP. So now the web servers are only getting, in most cases, valid requests. Yeah, sure, a few might still fit, trickle through. That's what we call false negatives. It's possible. But for the most part, they're just getting good requests and serving up responses. And we're doing all the security up on the front end, where it's easier to do, much easier than trying to do this coding within the web application. In addition, when we're hit with things like DDoS attacks, that's something else that ASM is incredibly good at doing, where the web servers may have had a very difficult time responding to your standard layer 7 DDoS attack. ASM can do it very easily. We'll talk about it a little bit later on. Also, when we have a new potential threat, something that Kevin just worked on this morning, he's putting together a new attack. And now he's got that new attack and he's going to start putting it out there. Nobody out there knows about this attack yet. None of these secure coders have anything in their web app to protect against that, and neither do we. We don't have anything on ASM yet. But it does not take much to identify that malicious request and then find some way to have ASM look for it. And we can create a custom signature in just minutes. Once I can identify the request, I can identify something about the request that is viewable, and I can create a custom signature and apply it up and immediately protect any of my web applications. I might have 10, 20, 40, 100 web applications down here, and they could all be protected in just a couple of minutes. Whereas if I was just relying on this and this alone, I would have to wait days, maybe even a week for a new patch to come out. And until then, they would all be vulnerable. So we can get that done up on the ASM in sometimes just a matter of minutes. So this is why, even if the customer says, hey, I've got all of these measures in place, my coding, my patching, that's what I go out and say. Why do I want to make my web servers doing this job? It's not their job to do that. Not when we have something better to do it and faster to do it. Any questions? This is my argument. You go out and make the same argument. So again, that 2 days. There you go, that slide. So let's talk about what could happen. What are some of the issues that could happen if we don't block it and that application attack may now be on the web server? It made it all the way through and the web server is now processing that attack. It can do a variety of things. it can expose confidential data on any of these servers involved, like password files and any information about the operating system, expose anything about it. They can run commands. They can run any kind of a command that we could run as an administrator on this server. Any kind of a command. So imagine anything you could do from the command line, they could do it. We could take off servers offline, just like we could in a network attack. Something as simple as just taking the servers offline. If they make it over to the database, again, this is where all of our user data is stored. So they could expose any of this user data potentially. The one that stores all of our credit card numbers, the one that stores all of our medical records. So I can view all of my medical information now online. Our username and password lists for Facebook, Instagram, anything that is stored in a database could be retrieved by the hacker and sent to them. They could also delete data or damage data, modify it, make it unusable. That's also not good. So those are some dangerous things. All can be very, but again, going back to the network attack is bad because it takes us offline. That's not good. But these kind of attacks, we're going to be losing potentially our customers' data. That's not good. When an organization makes their customers' data potentially exposed, then they have a lot of fixing to do. They need to go and fix a big problem, especially with their customer confidence. So those attacks have to be prevented from ever making it to this web server, ever getting there. And we're, of course, going to recommend doing that with ASM, our Application Security Manager. Putting that between the clients and the web servers. The way that ASM is going to work, so what we're going to do today, is you're going to create a security policy. An ASM security policy. What do you think you're going to attach that security policy to, by the way? A virtual server. So we might have 10 apps. Each app is represented by a different virtual server, and each virtual server can have its own security policy. That's actually really important, by the way, which I'll get back to a little bit later on in this lesson. So now that I have a security policy, every request that comes through, ASM is going to examine the request, and it's just going to verify one thing. Is there something malicious? Based on that security policy. Based on the policy. For example, in my policy, I'm doing checks for signatures to see if they match a SQL injection attack. That's incredibly easy for ASM to do. You can recognize just about any SQL injection attempt, and if it recognizes that, it's just going to block it. It won't go anywhere near the data center, anywhere near the web server. But if it doesn't identify anything malicious, it will then send the request on through to all the layers of the web application. We can also take a look at the response requests, the responses, the HTTP responses that are going back to the users. And we can make decisions about that too. For example, I could look and see if maybe there's some confidential data being sent back in the response. And I can address that. So that's how ASM works. And ASM has many different security features that we can enable. Can enable. We don't have to enable them all. A lot of different things. Anything from the very standard OAuth protection of SQL injection and Crosssite scripting. Some of you tomorrow are going to do a Crosssite request forgery demo. You can show how we can add that protection as well. Brute force protection, I think we do it better than anybody. I think our brute force protection is amazing. And that's a huge security threat right now. So the fact that we can just add that to a security policy, and by the way, we can add it really easily, is pretty cool. Some of you are going to be playing with some of these in your demos tomorrow. But I want to remind you that I don't want to start trying to add any of these really great features until I have built a good security policy to begin with, which is why we're going to be covering that today. I want to have a good security policy in place. And the way that I like to share it is the creation of the security policy. Getting the security policy, that's probably the hardest part. Getting that done. Adding most of these features, at that point, is usually a checkbox here, a drop-down list there. A lot of times, they're so easy to add these features. But we want to make sure we add the features to a well-built security policy to begin with. I also want to talk a little bit, just briefly, we're not going to go into a lot of discussion today about layer 7 DOS and botnet detection, but I want to talk about the fact that there are actually two different things that ASM can do, and they're actually kind of separate. Do you remember how in AFM was the same way? It had two things. We have firewall rules. I can look at all the rules. But before firewall rules, we have the network DOS protection. And the network DOS protection is a separate feature. There are two separate things that AFM can do, and you layer them together, it is really good. ASM is very similar. So for example, let's go back to the SQL injection example. I mentioned that Kevin's working on a lot of tricky stuff over here. So he's going to try to send a SQL injection attack to our web server, but Shudong is the ASM. And he's going to look at that request, and it's very easy for our ASM here to look at that request and say, that's SQL injection. Start, blocked. Oh, that's cross-site scripting. Come on, give me a break. That's simple. Block that. The ASM security policy can easily identify a lot of these kinds of malicious requests, and block them. But then Kevin gets this idea, well, let me just access the home page, the LoRax home page. Now that request is not malicious. So there's no reason ASM's not going to go back, get the web server, and send the web page back. And he notices that on that web page is the logo, the LoRax logo. Every time any one of us pulls up the LoRax web page, one of the requests to the web server is, I need the logo. So then he tries to just request the logo. Just go ahead and just request the logo. Again, when ASM receives a request for the logo, that's not malicious. It gets request for the logo anytime somebody requests the home page. So ASM's going to send that request back, the response back with the logo. But then he puts together a little script. And all the script does is request the logo, request the logo, request the logo, request the logo. Many times, as fast as his computer can do it. And each one of those requests is still going to be looked at as valid. They don't contain a SQL injection. They don't contain a cross-site scripting. They're not malicious in nature. So ASM's just going to keep sending those logo responses back. There you go, there you go, there you go, there you go. But then he gets that script and he puts it on your computer, and yours, and yours, and yours, and a bunch of other computers. So all these computers are flooding the web server with requests for the logo. Now in truth, all of those requests are still valid requests. They're not malicious in nature to look at. But if ASM doesn't do something with that, then it's going to flood the web server, and the web server could potentially go offline trying to fulfill all these requests for the logo file. For that, ASM needs to do a different kind of protection. It needs to be able to look at these requests and examine whether those are humans submitting those or not. If there's some sort of a bot, some sort of a script. And so ASM can do things like submitted JavaScript, a JavaScript response, challenge, a capture challenge could be one, a client-side integrity defense. We could do a few things. We could challenge the computer to see if a real browser is sending that. That's our layer 7 denial of service feature. That's a separate feature, and it's an amazing feature. It's really great. Our botnet protection, amazing. But they are two separate things. One is done by creating a security policy. The other is done by creating a layer 7 denial of service profile. They both can be used. I would recommend we use them both, but they're both looking for different kinds of threats. And thank God we have them both available. Because the second example I just gave you is the more common one that we're seeing now. And we have to be able to protect our web servers from that. So I just wanted to sort of give that distinction between these different kinds of application threats. ASM handles them, protects against them all. Of course, we want to layer it with AFM, so now we have layer 7, we have layer 7 denial of service, but also layer 4 and 3, and even a little bit of layer 2 denial of service, and firewall rules and all that great stuff. So this table is just something that it was shared with me a while back, and I thought, you know, it reminds me of any of those tables that our competitors have, where their product is matched up with somebody else, and their product always has all the checkboxes. No matter what, they've always got all the checkboxes. But these are a bunch of very common, well-known application threats over here. And you compare it to a network firewall, an intrusion protection system, and ASM. Does it do any protection? Does it do a little bit of protection? Does it do full protection? Well, look, there we go. We got all the checkboxes. That's great. But you know what? I can do a demo on any one of these. I can demo all of these and show you that ASM does full protection. If your IPS competitor says they can do something that we don't have them listed for, ask for a demo. Let's see it. Let me see you do it. I can show you a demo right now about ASM. Let's see you do a demo on your IPS. We have full protection on all of these threats. So what's driving our ASM sales right now? I think one of the main things, one of the main drivers is just the state of the application security world that we saw a few slides ago. The fact that we continue to see news. Regularly we see news of well-known applications, well-known companies that have had a data breach, had their applications damaged, hurt, or exposed. In worst cases, exposed. When we see that, that is an easy way to go to them and say, hey, I tried to get you to buy ASM. I was here twice. ASM would have protected you. Can we now make this sale? Or I can go to another company and say, hey, you're a very similar company. Do you see this news? One of your competitors just got breached. We don't want you to be in that same boat as them. Let me show you how I can protect it so that your company, your website, does not experience that same problem. We also have compliance requirements that a lot of organizations have, like PCI compliance. Which of our organization types have PCI compliance requirements? Sorry? What's one of the defining pieces of information that we're dealing with that recognizes PCI compliance? Credit card numbers? Yeah. So any web application where credit cards are a part, they have PCI compliance requirements. And a WAF is one of the few ways they can achieve PCI compliance. Some of you tomorrow are going to do a demo on PCI compliance and a feature that we have to fix that, to make it real easy. And then just following the trends of the OWASP, which is the Open Web Application Security Project. They're the ones who put together the top 10. And this is actually interesting, that some of you may not know, this is an interesting fact. This is not a company. This is actually just a group of people that are all very passionate about application security, web application security. And so if you want to stay on top of what they're viewing, they've got a website that I recommend you go look at. And that can also help you drive some sales by staying on top of what they're learning. Since I've been here at F5, I have seen such an increase in ASM interest and sales. And I think it's partly because the trends of the world, but it's also because the SE organization understands ASM a lot better. We can now go out and really share it. What's going on in this picture?
SQL injection.
SQL injection. Yeah. It's a strange license plate. If you've ever been sent something in the mail, say if I have or haven't, but maybe it's happened, where you get a parking ticket for going through a red light and have a traffic camera. Well, they're only taking a picture of one thing. They're taking a picture of my license plate. All that information, when they take a picture of yours and yours and yours and yours, it has to go somewhere. They're going to put it in a database. So that's an application, and that's a database behind it. That means all that data is vulnerable, and a savvy user might try to use their license plate to fool the server that's storing all that information. So yes, that's SQL injection, which is one of our OAuth top 10. Crosssite scripting. We've got quite a few things here. How many of these do you suppose could be mitigated with an ASM security policy?
Oh.
All of them. Seriously? You think all of them? We've got 3, 4, 5, 6, 7, 8. Oh, yes, all of them. Yes, ASM can help to mitigate all 10 of the OAuth top 10. Do you think this is something worth sharing with a customer? I think that's pretty cool. I think that makes ASM pretty valuable in their eyes. So before we get into discussing some of how these attacks take place, let's talk about how we as users, when you're going to go and you're going to book online travel or anything else, you're going to do your online banking, how do we interact with web applications? And don't say a web browser. Yes, you use a web browser or your phone, but within a web browser, what is it within your web browser that enables you to be interactive with a web application? Such as log in, post comments, book a travel. What is it on a web browser that lets you do all that?
The user interface.
What do you mean by user interface? User interface, yes, you've got the screen, you've got your mouse, but what is it on the web browser? What is it within a web browser that enables us to interact?
HTTP protocol.
Yes, the HTTP protocol, but more specifically. How do you log in? You don't log in with the HTTP protocol. It's used, but how do you log into a website? I'm sorry?
Login and password.
And what do those go into?
What's the
A form which contains what?
fields?
Field. Okay, I know this sounds very basic, but I'm trying to get to that point where, yes, we interact. The reason we can do pretty much everything that we can do on a web application is because of those things, those fields, username and password, all of these. These are all called parameters. We also know them as fields. Form fields, input fields. This is what makes it possible for us to do pretty much everything we can do with a website. And as I said earlier, when there's something that's helpful for us as users, there's someone who's going to exploit that. Hey, I can take advantage of that. Because it's these fields. These fields are how a majority of application attacks are sent to a web server. They use these fields to do that. For example, with SQL injection. So this is my login page for my bank. Now, if you've ever done any work with a database design, and actually before I ask that, I'll give you an example here of what I'm talking about. Raise your hand for me if you are, I'll change my parameter. Raise your hand for me if you're over 35. Over 35. Raise your hand if you're over 35. Okay. Now raise your hand for me if you're over 35 or if you're a female. Raise your hand if you're over 35 or if you're a female. Raise your hand. Are you not a female? Okay, just checking. So the fact that I used the or statement meant that you would now be raising your hand if you satisfied either of my two criteria. And if I had a third criteria, that would give a third option for you to raise your hand. The or statement, when you're doing database design, quite often you have multiple search criteria. You could say, find all my customers that are in Seattle and have made a purchase this last year. That and means I'm getting a small set of responses. Only my customers in Seattle that have made a purchase this last year. Whereas if I said, find all my customers in Seattle or customers that have made a purchase this last year, I'm going to get every customer in Seattle and every customer that's made a purchase. So the OR statement is a way to get more responses. So when I log into my website and I click on sign on, that's going to send a request back to my database server that says, hey, can you go look at our database and see if you can find a user, one of our user accounts where their first name is this, their username is this, and their password is this. And I'm only going to get a response back if there's a matching entry. But what injection users do, those hackers out there, malicious ones, is they'll try to log in with this kind of a concept and then send that. And what they're doing is they're attempting to append something to that SQL statement. So we're still going to send a request to the web server that says, hey, can you please send me an entry, a request if there's one that exists, where the username equals all of that and the password equals that, or 1 equals 1. So now the SQL server is getting two criteria. Find a request where the username equals this and the password equals this, or second criteria, 1 equals 1. And guess what? 1 does equal 1. So this criteria is going to be a positive result. It's always going to be a positive result because 1 always equals 1. So what they're attempting to do is trick the database server into having some sort of a positive response, sending something back as a result. And this is a very basic SQL injection. More often than not, they're going to be adding a lot more to this. That doesn't just look for data. It is actually asking them to do something with the data after this. Now, good sophisticated SQL injection strings might be kind of tricky to write. Oh gosh, how am I going to write those? Where could I possibly get some suggestions or examples on these complicated SQL injection strings? I'm sorry? I could just Google it. There's so many examples given out there as starting points. And again, my network firewall is going to pass this right on through because this request is still going to the web server on the right port. So we have to make sure that if the application server, if the web server sees that, it's not going to be so stupid as to send that request to my database. If it does successfully exploit this vulnerability, then the database server is going to run that and do whatever is after that or 1 equals 1 or however they write it. It could then say, and then send this kind of data. Then go into the credit card table and grab all the credit card numbers and send them to me. Or it could say, then delete all these records or delete this entire table. All they need to do is successfully fool the database server into this second OR statement, and then they could write code after that that does anything they want to do. Quite often, what they need to do is slowly find out about this server. So they could make the very first, if they can just get the first call to go through, the OR 1 equals 1, let's say, and they get a positive response back, then their next call, they could say, show me your database name. And they get a response back, oh, here's the database name. The third call, go into the database and show me all your table names. Oh, here's all the names of all my tables. Go into this one table and show me all your field names. Oh, here's all the fields from this one table. They're getting a picture of this entire database server from one call after the next. Now once they know all the field names, now they know what fields to ask for. Oh, there's a field called credit card number and a field called expiration date. Send me those. So it's kind of a back and forth process they take to get all the information they need so they could then carry out their attack. As a reminder, saw this earlier, this is still 1 out of 3 of the threats that organizations are facing. So even though this really should be fairly simple to stop, clearly it's not being stopped. ASM can do it incredibly easily. Cross-site scripting is another very, very common attack type. It can be very damaging. And because it's very damaging, and quite honestly, it's fairly easy for the hackers to do, it's still being used quite a bit. Let's talk about, in general, how cross-site scripting is done, and then we'll look at 2 different kinds of cross-site scripting. But the idea with cross-site scripting is the hacker is going to, in some manner, the hacker is going to make the victim, which could be you, any one of us could be the victim here. The victim isn't necessarily the web server, although they could be, but in most cases, the victim is this user. What the hacker is going to do with a cross-site scripting attack is they're going to actually find a way to make the victim run a malicious request against the web server. The hacker doesn't make the request, the victim does. So again, what's interesting though is the hacker doesn't directly target the victim. They don't somehow get into your laptop. They can't get into the laptop. So they are going to find a way to make you do it yourself. Now, it's possible, but it's not the only way to do it, that we can get this script onto the web server itself and potentially harm a lot of users. We'll talk about that in just a moment as well. But what happens is, if the script is on the server, any user that then goes to grab that web page is going to get that script delivered to them. And again, the hacker wasn't even involved in that communication. Once the script was on the server, any victim that pulls up that page could potentially run this malicious script. Because all of our browsers run scripts. Every web page uses scripts. Every web page uses some sort of JavaScript code. So our browser it's not going to be surprised to have some script in the web page. It's kind of expecting it. And the browser isn't smart enough to recognize good script from bad script. Again, huge vulnerability out there. And it still is at the top, one of the top vulnerabilities. Because there's so much damage that can be done to a lot of us out there. Where, again, hackers are now going to be affecting all of us collectively. So let's talk about the 2 different commonly used cross-site scripting attack types. The first is known as persistent. By persistent, what that means is we're putting something somewhere permanently. The hacker is going to put something somewhere permanently, like the web server or the database server. So the first thing the hacker is going to do is they're going to get some sort of a web server available like this. This could be on their own web server that they own. But this actually could be a hijacked web server. The owner of that web server doesn't even realize that some other web page has been loaded up on there. So all we need is all the hacker needs is to be able to point people to this URL. And this could actually be an IP address. It doesn't even have to be a host name. It could just be an IP address. Then they're going to access a website, any website that is popular out there in the world. Facebook, Twitter, anything that a lot of users are using. In this case, I've got the Internet Movie Database. It's another popular website. Go look at all the movie information that's out there. And the hacker is just acting like a regular user right now. I'm just using this website. I'm going to go look at a movie. And you know what? I want to create a review. I want to write a review for this movie. When I write the review, I'm going to exploit one of those fields. There's another exploit of the field. Now these kind of fields are very popular for cross-site scripting. When I say these kinds of fields, I mean the fields where you have a lot of characters you can type, like a Facebook post. Anything like that, where I could type 10, 20, 40, 80, 100 characters. And cross-site scripting involves writing some sort of a script with a start script tag and an end script tag, and whatever goes inside of it, that's just for the hacker to know how to write. Anything somebody can write in script, in JavaScript, could be placed inside of there. Now this is a simple script. What I'm saying is go into your browser and grab your cookies and then send them somewhere. Hey, where do I want to send them? Oh, look at that. I'm going to send them here. The hacker site. Simple script. And what they're going to do is they're going to submit this. Now when they submit this movie review, where is that movie review tentatively going to go? Where is that review going to be placed inside of our organization? It's got to go in a database. It has to go in a database. The only way that I can put in a movie review myself as a non-malicious user, and Kevin can view my movie review, is if it's in a database. So that when he goes to look at Internet Movie Database, we'll pull that review and all the other ones to his browser. So we have to put that review into a database. That's what makes it persistent. Now, that script is in my database. That malicious script is in my Internet Movie Database. That's kind of tricky to say. Now we have this innocent user out here. They're not a bad guy. They just want to go and see all the movies that are out there as well. And one of them happens to be the same one that we were just manipulating there with a bad review. So when they say, hey, can you send me all the reviews for the Avengers film? The database says, yeah, let me go grab them all. There's 50. And one of them happens to be this one. And they all get sent back. All those reviews get sent back, including that one. And then my web browser creates the page. My web browser is going to create the page so I can view it. And when a web browser creates a page, it does all the HTML or XML and runs all the scripts. Any scripts that are on the page. This just now happens to be one of those scripts inside of that web page, which is now going to cause this client to go into their browser cache and send the cookies to where it's told to go, the hacker server. Now the hacker has all that cookie details about that victim. If we're going to look at that web page, go and look at the code of it, you'll see that script is indeed one of the components that built that web page for the user. And they had no idea anything just happened. I mean, they literally will have no idea anything bad just happened to them. That's our persistent, because now another user goes to view that same movie, and another user goes to view that same movie, and another one. Every user that goes to view the reviews for the Avengers movie is going to send their cookie details to that malicious hacker. And I guarantee you this, the hacker didn't just place that cross-site script into one movie review. They probably tried to get it into as many movie reviews as they could, so that all these users viewing any movie review list is going to run that cross-site script. Dangerous stuff. Now we also have what's known as non-persistent or reflective cross-site scripts. These are not going to place anything into a database because these are affecting websites that don't have a database. We don't store data. So you would think that they're not vulnerable. There's no vulnerability there. But there is. The way that this is done, though, is different. The hacker, the malicious user, is still going to utilize their web server that they've created or they've hijacked in some manner. But this time what they're going to do is they're going to create a link. This is an A link, if you're familiar with web coding. So they have some sort of a text. Check this out. Great offer. This is amazing. You have to click on this. The A link starts the actual link. The A tag starts the link. Notice the link is the exact same thing that we saw earlier. It's going, actually, no, excuse me, I'm sorry. Let me rephrase that. The link is going to the legitimate website, the NWB database. It's using one of the features on that page, the search field. That's the field I use when I'm searching for a movie. And when I search, there's a parameter used in a search called keyword. But what I'm doing is I'm making the user send in their search parameter that same script we just saw earlier. This is the exact same script that says, go into your browser cache, get your cookie details, and send it to my server. So we are now going to send that link. And where does the hacker want to send that link? They want to get that link into as front of as many people as possible. They want as many people to see that link as possible. How could they do that? Where could they put that link?
Email. Cache.
Email. Where else?
Cache it, like your browser cache.
Well, they can't get it into my cache.
RAM.
They can't get it into my cache. They could certainly send an email to a bunch of people. Where else can we place a link that other people might click on?
Advertisement.
I'm sorry?
Advertisement. Advertisement.
Advertisement.
Oh, an advertisement. Okay. But where can I put an advertisement? Where can I put something that a lot of users will see and maybe fool them?
The fake legitimate website.
I could create a fake website, sure, but now I have to get people to my fake website. Are there any real websites out there that a lot of users use?
Forums.
And the-
Forums.
Okay, forums. You guys are going about this the hard way. How about just using any social media site that's out there? Any social media site that's already out there, and I can create some entries, I can create posts where I have a link. Because all the users are going to see is, check this out. This is a great offer with a link to it. That's some of the main tools that these hackers use. They definitely try to email this out. They try to email it, but then I have to have an email list. I might have the email list, but I could just place this link on as many social media platforms as I can get my hands on. Because now when this user sees that link and they click on it, when they click on the link, it's going to do exactly what the link says to do. It says, hey, go to this website. They didn't even know they were going to the NWB database. That's not what they were thinking they were going to do. But they're going to go to the NWB database. They're going to submit a search. And then this is what they're searching for. The website is going to run that script. I'm sorry, it's going to run that link. It's going to say, oh, okay, here's the search results. Here's the search results you just asked for. You searched for this. That's the text you searched for. That's going to be within the response. And because it's in the response, there's a script. There's a script inside of my browser. And again, my browser is going to run this script because that's what the browser is supposed to do. It's still going to run the script, and it's still going to now successfully send the cookies to the hacker or whatever else the script is written to do. And again, you can do whatever the scripter knows how to do. So in this case, the web server didn't even know anything happened. It just got a search request from somebody and said, here's your search results, that's it. The client may not know anything happened. They just got some pop-up page on IMDb, but they don't know what happened. So this is the cross-site script attack where we don't even need a database. We're just going to fool victims into submitting requests that contain the scripts that I wrote. Both of these need to be stopped from going to that web server. I can't protect all the clients of the world. I can only protect my web server from allowing those requests to come in, either from the hacker, where they're trying to do a persistent script into my database, or from that victim who didn't even know they were about to submit a cross-site script request. Both of those have to be stopped. So to do that, ASM needs to be brought into the mix. We need to get ASM involved because ASM, before I ask that, how many of you would answer this question affirmatively? How many of you would say that you consider yourself kind of an HTTP expert? No hands. Okay. That's okay. That's fine, because we do have an HTTP expert on our team. And the HTTP expert is ASM. ASM knows every single thing that there is to know about the HTTP protocol. But for you guys, we're going to do some review of an HTTP request so that you can see all of the pieces of a request that ASM can help and protect. We'll start with what's called the request line. In an HTTP request line, we have first the method, the HTTP method. There are a couple of commonly used methods like get and post. Whenever you're just trying to view a page and that's it, you're probably using a get request. Go give me that page. When you're trying to send data in form fields, put in your name, password, whatever, and you click on a button, quite often we're trying to put that data into a database, and that uses the post method. So those are the two most commonly used HTTP methods. You've got these others here that you might see from time to time. Then we have the actual URL that we're going to, also known as the URI. That's the page we're going to. And then finally, the version, the HTTP version that the client is sending. So this will say if the client's sending over HTTP 1.1 or HTTP 2.0 or whatever. In addition, we have our HTTP request headers. This is where the web browser sends a lot of information about itself to the web server. So the web server knows a little bit about the web browser. And then finally, if it is a post request. If it's a post request, that means I am sending some data in a field. For example, here's my movie review. The movie review is going to be text I'm sending inside of the HTTP request body. So the HTTP request body contains any fields that we have submitted to the web server. Both field names, these are my 3 field names in this request, and then the values that the user themselves submit. Their first name, their last name, their email address. Now these parameters are actually something that we're going to be doing a lot, potentially. We're going to potentially be doing a lot with these parameters with ASM. So I want to spend 2 slides. That's an extra fix I got to do on my slide there. The parameters are, there's 2 different methods that web developers use to take parameter values that you enter in a web page and send those parameters over to the web server. There are 2 different methods that are used. The first method is inside of a query string. So for example, I'm on Bing, and I'm going to do a search for F5 networks, and I click on Submit, whatever the button is. I click on Enter, and then I get my result. Now at this point, if you look up in your URL box, you'll see 2 things. You'll see the name, the page, the URL that I was going to, the URI, but then you'll also see a question mark. The question mark is our way of knowing that everything beyond this question mark are going to be parameter names and parameter values. And each parameter name starts with whatever the name is of the field and then an equal sign. So in this case, I know that this parameter name on the web form is called Q. You'll find that the parameter name for Bing and for Google and for Yahoo, they always name this field Q. What do you think that's for? Query. Assume, yes. Who's responsible for creating that name, the name of that parameter? Not the browser. The browser didn't do it. I'm sorry?
The user,
What user?
the end user.
The end user can't change parameter names.
Programmers.
I'm sorry?
Oh, the script.
JavaScript doesn't change the name of this parameter. Where did the name of that parameter came from? Who came up with that name? Q. I'm sorry? I thought I heard it.
Web server.
The web server doesn't create parameter names. That name could have been called Q, it could have been called Q1, it could have been called query name. That parameter could have any name. Somebody came up with that name Q. The developer, thank you. Whoever developed this web page came up with that field name and every other field name. I bring that up for a reason. Because sometimes our parameter names don't always make sense. Why has this parameter got this weird name? Well, that's what somebody called it. Whoever created that page. That's the name they gave it. They had their reasons, who knows why. But after each parameter name and the equal sign is where you'll then see the value that was submitted by the user, the end user. In this case, F5 Networks. Now you'll notice they're not quite perfectly in line. This says F5 Space Networks, but this says F5 plus sign networks. So the question I have is, why is there a plus sign up there and not a space up there?
We are not allowed to use spaces in the URL.
We're not allowed to use spaces and many other characters, by the way. There's certain characters you'll never see in the query string because they can't be submit in the query string. And so they'll get replaced by some special characters that you'll see, including the plus sign. So this is one method that developers use, web developers, to send this parameter information to the web server. Do you suppose this is a good way to send, for example, the username and password fields to the web server? Why not?
Because it's in clear text.
It's in clear text. We can see it. And not only can we see it, we could actually come up here and I could change this text and then hit my enter key, and I could send another request just by doing that. I can see these parameters, and then I could modify these parameters and resubmit my request very easily. That's what the request line would look like, by the way. This is a GET request. I'm not posting anything into a database here. I'm just saying, go get the page, and this is my full URI. Notice the URI includes the question mark, the parameter name, and the parameter value. The other method that is used to send parameter names and values is through a post data request. This is what you're going to typically see when you are submitting data into a database or getting data from a database. We're actually interacting with the database to put data somewhere. That's the safest method. So here's my Facebook page. I'm logging in as Bob Smith using the password that I can't see, password type field. I'll click on that login button. Now sometimes, as I said, not only is it nice to know what those parameter names are, but if I'm going to do a lot of work with a security policy in ASM, I actually have to know what those parameter names are. It's going to become critical for me to know whatever this web developer chose to name these fields and probably all of those as well. So an easy way to do that is just to view the source code of the page. And in the source code, I can see, oh, there's my first field. And what I'm looking for is the name attribute. So the first field's name is email. The last field's name, the second field's name is pass. Huh, that kind of threw me. I would have thought they would call the field password, but they called it pass. That's good to know, because that might not have been intuitive when I just saw that field name randomly put in a list. So this is what the request is going to look like when I do a post request. It's still going to be a standard request line, post, but notice nothing's after here. There's no question mark. There's no parameter names and values being sent in the query string. All of the parameter names and values are sent in the data portion. So every parameter name and value, and they're separated. Each parameter name and value pair is separated by the ampersand. So I could have 2 parameters, 3 parameters, 5 parameters. I could have a ton of parameters sent in one request, and we separate them each with the ampersand. Also notice that we don't show the parameter, the password name. Password style fields don't get sent in clear text, which is good. So I wanted to point that out because it is good to know when you're dealing with a lot of parameter security. How do we interact with parameters on the web page? Those are the 2 different methods. Query strings or post requests. So now here's my full HTTP request. The request line, all the request headers, and the optional body, which we do have a body because this is a post request. And I'm going to talk about all of the different aspects of this request that we can protect with an ASM security policy. Starting with RFC compliance. RFC compliance checks, there's about 10 or 12 of them, I think, in total, maybe 14. It's a variety of different checks. These are just making sure there's standard practices being applied in this request, such as it's a valid method. It's got to be a valid method. It's a valid HTTP version. All of these request header values are valid, that they all have valid data in them. It has specific headers that it's looking at. For example, it checks the content link header and makes sure that's a positive number. It's a numerical number. It's going to verify that. It always requires an HTTP host header. If there's no HTTP host header, it will not be RFC compliant. It also verifies that if it's a post request, there are potentially some parameter names and values, but these should only be in a post request. And then finally, it verifies that every line has these standard end-of-line markings, the /r/n. So these are just some standard compliance checks. And every single security policy you're going to create will always include these checks. It's actually kind of just some basic stuff. But then we can go one step farther, and we can check for some link attributes, different link attributes. For example, you can see right now that this request, if I was going to guess, I would say that's about 400 characters long, maybe 500 characters long. What if some malicious hacker was manipulating HTTP requests to send to the web server, and all of these requests were 100,000 bytes long? And we were just sending all of these requests to the web server of 100,000 bytes. What kind of an impact is that going to have on the web server?
Buffer overflow.
I'm sorry?
Buffer overflow.
It's going to be a lot of data for the web server to be looking at and trying to process when most of that data is invalid. So we want to prevent things like 100,000 byte requests from hitting the web server by doing some link limit checks. So there's a few things we can check for link limits on. The URI. We can make sure that the URI is at 1,000 characters long. That'd be a very long URI. That's the web page. That's the page itself. Then we have the URI. So we can verify the page link. We can verify the URI link. We can verify the length of all these parameters that were submitted. So we can make sure that their last name isn't 5,000 characters long, or something like that. But then we can also verify the entire HTTP request length and make sure it's not more than a certain number of characters. like 5,000 characters long. If it is, we call it malicious. We can also go one step farther now, add some more security by applying what we call file type enforcement. This is what we're going to do in lesson 2, by the way. With file type enforcement, we can ensure that only the file types we need for our web application, and most web applications only use 10 or 15 different file types. For example, this web application uses the PHP file type. It uses the HTML file type, the PNG file type for images, as well as .js for JavaScript files. Those are all file types that are needed for this web application, and we can lock it down so that ASM only passes requests through for those file types. So if somebody tries to request an exe file type, we're not going to send it to the web server. This is also a valid file type. There's nothing there, but a lot of my users request my website like this. They don't put in a file type. f5.com/default.asp. Our users don't type that in. They just go to f5.com, enter. So we have to think of that also as a potential file type we want to include. So file type enforcement, as you're going to see in lesson 2, is a very easy layer of security to add. Very easy, and it actually adds some really good security. It's a good bang for its buck. We'll cover that in lesson 2. Now we can go one step farther. I have now identified PHP as one of my valid file types. But I don't want them requesting any PHP file under the sun. We only have a finite list of web pages that use PHP as the file type. So I can create the absolute list of all of the valid pages, URLs, for this web application. So not just PHP, but I'm going to say only signup.php and login.php and index.php and logout.php. Every page, every URL, I'm going to create a list for. I have now just added more security, but a little bit more work. It's more work to identify that list of URLs.
So we need to work with the application developer.
Of
to
course.
understand what we
Yes, we'll talk about that in lesson 2. Absolutely. I can even go one step farther. We have all of those parameters. First name, last name, username, password, credit card number, whatever all these parameters are. And I can lock down the web application to only allow the parameters that are actually valid for this web application. So I'll create a list. First name, last name, email, username, password. And ASM will only allow traffic through if it has parameters in that list. If somebody tries to put some data into a parameter called hack, ASM is going to say, sorry, that parameter is not in the list. I'm not going to allow that. Now this has now just given us even more security than the previous example, but again, there's also a little bit more work involved to get this added. And we can even go one step farther than this. Not just identify all the valid parameters, but I can actually identify the type of data that goes into every parameter. For example, my first name field. I've defined a specific type of data. No more than 20 characters, no characters other than A through Z. So if somebody tries to submit a first name field with a number in it, it's not going to be allowed. If they try to submit a first name with 30 characters, it's not going to be allowed. But my email address can have its own allowed list of attributes. I'll allow them up to 40 characters. And I will allow A through Z, 0 through 9, and the @ symbol only. Whereas my password field, I have another criteria for this parameter. They can have up to 50 characters. They can add A through Z, commas, exclamation marks, hyphens, because we actually want users to be using special characters in their passwords, so we wouldn't want to lock that down. Now we've actually added even more security, but this is more work. Each one of these steps adds a little bit more work to creating the security policy. And then finally, we have our ability to use these attack signatures. We have a lot of different attack signatures, and the attack signatures are how we block all of the known issues. SQL injection, cross-site scripting, cross-site request forgery, and on and on. And what can I check in this request with an attack signature? Well, I can check the request line. I can check every single request header. I can check every parameter name and parameter value, because that's how they send SQL injection attacks. We can use signatures to check every aspect of the HTTP request. And then one last thing I mentioned briefly earlier. We can also check responses, HTTP responses from the web server to check for a variety of things. One of the really common ones is we can do content scrubbing if we see confidential data going out, like credit card numbers or user account numbers. We can identify those and scrub them out and replace them with like asterisks. That prevents data leakage. There's another item that's on this list that says checks for malicious patterns in the response. A malicious pattern is a fancy way of saying a signature violation. So in other words, we're going to look and see if the web server is sending some sort of a signature violation, like an attack signature, back to my user, to my poor innocent client. Now, I know my web server developers, my app developers, they're not malicious people. So how is it possible then that my web server would try to send something malicious back to one of my users?
If the web server has been victim of cross-site scripting injection.
Ah, yes. Remember we talked about that earlier. If somebody successfully got a persistent cross-site script in our database, now it's possible that when somebody goes to view the Avengers movie, one of the reviews is going to be that cross-site script. And we can identify that on the way out and potentially block that user from getting hurt. That's actually pretty cool. Now at this point, this is where a lot of people start to think, oh my God, that is a lot of stuff. That's like, that's more than I need. That's way too much. I'm sorry. Thank you. But I need something a little bit less complicated than that. What I like to do is talk about my home security. I actually did get some home security in my new house in Long Beach. And when you go get home security because you have some dangerous stuff going on in your neighborhood, I'm going to bring a couple of companies out to give me some estimates. And the first company that comes out, they offer me this solution, where they put these little stoppers in all the doors, so that if a door is shoved open, it creates an alarm. The good thing is they can do this pretty quickly. They can get this installed pretty quickly, and it's also fairly inexpensive. However, that's not quite enough security. That doesn't make me feel very confident when I'm sleeping at night and I hear this alarm go off. I don't even know if I want to go downstairs to check it out. So, thank you, but that's not quite enough. So then we have another company come in and give us an estimate. And this company has a system where they go through every corner of your house. They check all the ingress points. They do lasers, they do motion cameras, they do sensors. They have it set up so that even if somebody just, brushes up against one of your windows, their guarantee is a police car in your driveway within 10 minutes. And this is going to take a while, obviously a lot more expensive. And I'm thinking to myself, wow, I do a lot of gardening, and I might brush up against my own window from time to time. I certainly don't want police cars driving up, and that might be too much. That might be more than I need. What I really need is something better than this, but not quite as much as this. And that's the way security policies are done with ASM. Remember that a security policy is attached to every virtual server. So each virtual server can have its own policy. And we can have some policies that are like this door alarm. We're just checking for the bare minimum security, like signature violations. And that's it. That's all I care about. Are they triggering a signature violation? That might be fine for my public website that has no fields, has no login, no user interaction. But my other web application is my online banking. My online banking, where users are logging in, they're viewing their banking information, they're doing banking balance transfers. I need as much security as I have available for that application. So for that, I'm going to probably add things like file type enforcement, URL enforcement, parameter enforcement, and so on and so forth. So it's not that, oh, that's maybe more than I need. It's, you know what, I'm going to use what I need, and I don't need it all for this application. But you know what, I do need it all for this application. Thank goodness it's all there. Thank goodness ASM has all that security available. Now all I need to do is get a policy created and take advantage of it. So how long do you guys guesstimate that it might take to create an ASM security policy?
Depends.
It's going to request the amount by customer.
No, it doesn't depend.
So at first, I guess you have to create a general security policy, which takes about 1 to 2 minutes. And that's it.
You're way off. It takes about 30 seconds. To create the policy itself actually can take very, very little time. Now actually doing everything else we're going to do in lessons 3 and 4, really getting the policy tuned properly, that takes a little bit more time. But the actual creation of the policy, we've made it very easy. In fact, that's one of the things our developers have done with ASM is they turned the policy creation process into a couple of fields. That's it. You just hit a couple pieces of information, you're ready to go. With ASM, just like AFM, we're going to do everything on the security menu. We're going to go to application security. We have the new guided config. I'm not going to play with that today, but you certainly can play with that. That's one of our newer features with ASM, excuse me. We're going to use the security policies list page to create a policy. So when I click on the create new policy, there are really only 3 things you need, and 2 of them are really easy. The first thing you need is just a name. Just give the policy a name, just follow all of our BIG-IP naming practices, no spaces. The second thing you need, you will have to put a little bit more thought into. The second thing is the security policy template type you're going to choose. We have a variety of template types. At the bottom of the list there is a list of template types for some known applications like Outlook Web Access or SharePoint. One of the challenges in building these policies is this tuning process. It's getting potentially all of the file types we need, all of the URLs we need, maybe even parameters. If we're going to do parameter, all the parameters, well, it takes some time. But the nice thing is, if I'm going to do a policy for SharePoint, we already know the URLs for SharePoint, the file types for SharePoint, parameters for SharePoint. So these particular out-of-the-box application templates are designed to sort of help you get started quicker with policies. We're not going to cover those in class any further beyond that, so it might be something to play with on your own. We're going to focus mainly on these 3 throughout class today. Comprehensive, fundamental, and rapid deployment. We're not going to do passive. These are the ones where we're going to be doing everything from scratch ourselves. We're going to do all the policy building ourselves. And for now, we're going to use rapid deployment. Rapid deployment is used quite often by our own professional services to build security policies. There's a few reasons why we claim to use rapid deployment. The first is it minimizes false positives. What's a false positive?
Something that's not.
Anything which is not really anomaly, but it's just false positive.
Okay.
Benign traffic.
Denying traffic of what?
Benign traffic.
Oh, it's benign traffic. And what do we maybe do with that benign traffic on accident?
On accident,
What makes it a what would make it a risky false positive?
Because the traffic look dangerous from the ASM point of view, but it's a legitimate traffic.
And what does ASM potentially do to it?
It will block it.
Yeah, so potentially blocking non-malicious traffic, something that kind of looks suspicious. Organizations don't like false positives. They don't want people being blocked from accessing their online banking or their e-commerce site. So they like to minimize the false positives. Follow-up question, what is the trade-off? When I want to minimize false positives, what's the trade-off to that?
Reduce the security
Risk.
There's no way that I can minimize false positives and still block everything malicious. It's just not possible. The more I want to minimize the false positives, the more likely I'm going to have false negatives, which is allowing bad traffic. So we have to decide, that organization has to decide where they want to fit on the spectrum. By creating your initial policy with rapid deployment, it minimizes false positives. Why? It doesn't add a whole lot of security by default. That's why. It also decreases this time we have between what we call transparent mode and blocking mode. Every security policy has one of these two modes. It's either in transparent mode or it's in blocking mode. And what's important to understand from this point in the class is that when you have a security policy and it's in transparent mode, absolutely, positively, nothing gets blocked. Nothing will ever get blocked when the security policy is in transparent mode. More often than not, we're in transparent mode while we're building that policy up to completion. And then at a point when we feel that the policy is completed is when we would typically take the whole policy and move the entire policy to blocking mode. And that's when we can now start blocking malicious requests. But we can't just take part of a policy and put part of a policy in blocking mode. It's all or nothing. But of course we can have one security policy for this app that's in blocking mode and another security policy for this app that's still in transparent mode. That's completely possible. So what we say is when you're using rapid deployment, you can typically get to blocking mode a little bit faster. As you're going to see in your next exercise, we're going to protect against some of the most common OAuth attacks, like SQL injection and Crosssite scripting, in just a matter of seconds possibly, which is what you're going to do. We do that because of our attack signatures. So rapid deployment includes thousands of attack signatures, and we can even add more later if we want. But the default set is going to be quite a few attack signatures. So that's the second thing you need, is to know the template type. The third thing is just what virtual server we're protecting. So to create a security policy, 3 things. Give it a name, that's easy. Select the virtual server, that's easy. And then pick which template type. That's all you need to actually create your security policy. So I think you could do that in 30 seconds, potentially. I guess it just depends on how fast you can type this. And then you click on the Create Policy button. Now, of course, we're not going to be done. We're going to add more security later, but that's going to be our starting point. And that'll be your starting point for you guys today. But before I give you the introduction for the exercise, that's our real overview. The rest of the day, we're going to start getting into the actual nuts and bolts of ASM. So in an overview perspective, why this product is important, HTTP. Is there any questions?
Does ASM protect the
To which?
zero-day attacks?
Oh, absolutely can, with some help. We also can use, dynamic signatures as well, which takes us above and beyond even more. But yes, we say yes, it can. Now, there's always going to be the moment Java has created that new attack and he sends it out, from the very first request or two, we can't always know that it's malicious. It's new. It's new. There's always going to be a period where something malicious may not be known as malicious quite yet. But we can get it blocked fairly quickly with ASM, much faster than without using a WAF, without using ASM. But until we have any idea something's malicious, and to be quite honest, we wouldn't want to do it any other way, because that's going to increase our false positives. When I don't know something's malicious, we don't typically want to block it right out of the gate.
How does it know that it's an attack?
That gets us into a rabbit hole. All I'll say is this. When we're using something like a dynamic signatures, what's going to happen is when ASM sees something that looks a little suspicious, that looks a little weird. It doesn't fit the norm of what I'm used to, but you know what? I'm going to go ahead and send it on to the web server anyway. And it's going to keep doing that, but it's going to be monitoring the web server. And if the web server appears to be getting overloaded, that's when ASM says, you know what? This suspicious looking traffic is harming my server. So I'm going to actually create a brand new signature just for this. I'm going to recognize this traffic now, and now we'll start blocking anything that matches this new signature I've just created. So we don't want to just block it immediately until we know it's actually harming the web server. And ASM can do that all on its own without our help at all. So that's about as much of an answer as I'm going to give now without going too deep into the weeds.
So it creates a signature in real time, applies it.
Absolutely. That's one of our standout features with our Layer 7 DOS. That's not part of a security policy, by the way. That is not part of the security policy. That's part of the Layer 7 denial of service, which is the other feature, more of an advanced WAF feature. But it's an amazing feature, and it really is an important feature. All right, so what you're going to do in this exercise is, and actually one thing I really kind of find funny about this exercise is I'm giving you about 30 minutes, and about 25 of those minutes you're going to be spending doing malicious stuff. The actual mitigation side is going to be really quick. What you're going to be really doing is being a malicious user. You're going to be using our damn vulnerable web app to launch some SQL injection attacks and some cross-site scripting attacks. And then you're going to create your new policy from scratch. And you should see that within just a second of creating that policy, those attacks are now affected differently. You should see a big difference. And then one of, I think, the best aspects of ASM is our log file. So I'm going to give you the opportunity to go in and take a look at the ASM log file. It's also break time, so why don't we take till about 11 o'clock? And call me over if you have any questions during the exercise. Otherwise, we'll see you guys at 11. Move on to lesson 2.